All right, hello math fans. All right, so today we're going to do solving rational equations. So solving rational equations. And it's actually very similar to simplifying rational expressions, which we spent several days on. Okay, but we're actually going to start out with kind of a basic problem. All right, we've actually seen these already. So here's I just have a bunch of examples to give you guys. 3 over x is equal to 2 over x minus 5. Now, one thing I want to point out here is there are two rational expressions. Okay, two rational expressions. 1, 2. If there are two and you have 1 is equal to 1 rational expression, what you're going to do is you're going to cross multiply, not cross cancel. Sometimes you guys are used to that. You're used to, where you have, 2/3 times 6/5, and you go, oh, that's a 1 and that's a 2. This is not what we are doing. We're not cross-canceling. That's really important. We're cross-multiplying. So that means it's saying 2 times x equals 3 times x minus 5. Okay, so you get 2x is equal to 3x minus 15. When you distribute, we're going to move the 3x over, and we're going to get negative x equals negative 15. Divide by negative 1, x equals 15. Okay? The only thing I want to mention here, okay, that's our answer. And if you guys remember back in the day when I said, where's the rational expression not defined? Okay, and you remember what you did? So the question is, where is the rational expression not defined? Okay, where's the rational? So what you're going to do is you're going to look at the bottom and you set the bottom equal to 0. So for the first one, it's 3 over x, so x equals 0. And the next one is x minus 5 equals 0. So this one's already solved. This one I add 5 to both sides, and I get x equals 5. So it's not defined at 0 and 5. And this is the deal. If this answer came out, this answer or one of the answers came out to be a 0, 5, you're going to cross it off because that's not one of the answers. It's impossible for that to be an answer. Okay? So in this case here, x equals 15, that's my answer. We're good to go. All right? But if it's not, then again, cross it off. All right, so let's do another example here. 2 over 3x is equal to 7 over 6 parentheses x plus 2. All right, so again, don't cross cancel, it's cross multiply. So we're going to multiply this guy together, so we get 2 times 6 parentheses x plus 2 equals 3x times 7, which is 21x. Okay, well I'm going to multiply that together. 12x plus 2 equals 21x, and then distribute. So 12x plus 24 equals 21x. I'm going to subtract 12x from both sides, and I get 9x equals 24 divided by 9, and you can simplify that. 3 goes into 24 8 times, 3 goes into 9 3 times. Okay, so x equals 8/3. And again, what can't x be? And you have to check that. Well, this one's, if it's just like 3x, that's easy. That's just x equals 0, right? And the other one, 6x plus 2 equals 0. So 6x plus 12 equals 0. Subtract 12. And you can almost see what these are. Divided by 6, x equals negative 2. You don't, you can almost look at this and say, for most of the problems, right, if I see an x plus 2 in the bottom, what can't x be? X can't be negative 2. If I just see a 5x on the bottom, what can't x be? 0. So if it's like a plus 2, just know, well, I can't have a negative 2 in there. Or if it's x minus 7, I can't have a positive 7 in there. Okay? So my answer for this problem is x equals 8/3, which is actually a good answer, and that's what you're going to put in the blank. All right? Okay, let's try another one here. 2 over x is equal to x plus 3 over 5. Okay? Same deal. Cross multiply. So 5 times 2 is 10. And then I can write this as x times x plus 3. Distribute. I get 10 equals x squared plus 3x. And then I'm going to move the 10 over. If it's quadratic, make sure you move it over so you can factor. X squared plus 3x minus 10 equals 0. And then I'm going to factor. That's going to be plus 5 and minus 2. So x plus 5 equals 0. X minus 2 equals 0. Minus 5, so x equals negative 5. And add 2. X equals 2. Okay, so my answers are x equals negative 5 and 2. Going back to the original problem, what can't x be? Well, this one doesn't matter, does it? Because I have a 5 in the bottom. And the only one I have to worry about is 2 over x. Well, what can't x be? That's, again, really obvious. X can't be 0. Well, are any of these 0? Nope. So my answer is both negative 5 and 2. Okay? So they're both good. All right, so we've actually done this before with 2 terms, with cross multiplying. But what happens if we have a problem where it has 3 terms? So 3 or more terms. Well, before I get started, I want to show you guys something. If I have x over 4 plus 1/4 equals 3/4. Okay, this is just really generic. And if the question is, how many, what do I need to add to 1/4 to give me 3/4? How many fourths do I need to add to 1/4? Do you guys agree I need 2/4? 2/4 plus 1/4 equals 3/4, right? So the thing I want to point out here is once I have the same denominator, okay, once the denominator is the same, I don't really need to worry about it. Okay, I could have actually said, I could say x over 5 plus 1/5 equals 3/5. Right? Isn't it the same? Wouldn't it still be 2/5? Wouldn't x equal 2? So does it even matter what the number is in the bottom? As long as it's the same, right? In other words, if I had 2/5, or let's say x over 5 plus 1/4 equals 1/3, that's a different story. Okay? But if it's the same denominator, then I don't even have to worry about the denominator, right? X over 105 plus 1 over 105 equals 3 over 105. What's the answer? Isn't it 2? Isn't that x equal to 2? Because 2 over 105 plus 1 over 105 equal to 3 over 105, of course. So the deal is, you need to get, so we need a common denominator, which we've been working with for a long time. And once you get a common denominator, so we need a common denominator, then just set the tops equal and solve. Okay, that's all you have to do. So in other words, if I look back at this original problem that I did here, I have x over 4 plus 1/4 equals 3/4. So I just need to do x plus 1 equals 3. I don't care about the denominator. So you subtract 1 from both sides, and you get x equals 2. And that's exactly what we said, 2/4, right? So x equals 2. Pretty easy. So let's do a couple problems now with that in mind. So remember, our goal, early goal, is to get a common denominator. All right. So 3 over x plus 2/3 equals 5 over 6. Okay, so Same thing as before with rational expressions. You need to find your LCD. That is super important. And if you notice, I have x, and I have 3, and I have a 6. Okay? So my LCD is 6x. So what I need to do is I need to multiply this by 6 over 6 to get that to be 6x. I need to multiply this by 2x over 2x to get that to be 6x. And I need to multiply this by x over x to get to be 6x. Once you have the same denominator, you cross them off, because I don't care about the denominator anymore, right? I just care about the top now. So I get 6 times 3 plus 2 times 2x equals 5 times x. And I solve. So I get 18 plus 4x equals 5x. Subtract 4x from both sides, and I get 1x, or x equals 18. And that's the answer to that problem. Now, once again, I'm going to ask you guys, what can't x be? Let's look at the original problem. It's kind of messy, so I'm going to rewrite it. Okay, so I'm going to look, well, I don't have an x in the bottom here, I don't have an x in the bottom here, I have an x here. So what can't x be? X can't be 0. Is that 0? Nope. So x equals 18 is my final answer. Okay? Let's do another one here. X over 2 plus 3 over 2x equals 2. Alright, well, what you need to do is, let's put this over 1. We want to make everything a fraction. And your LCD is, well, it's a 2 and a 2x here and a 1, so isn't the LCD just 2x? So that means I multiply this one to get 2x, I need to multiply by x over x. This one by nothing, and this by 2x over 2x, because I need all of 2x in the bottom. So here I have 2x, here I have 2x, and here I have 2x. Cross them off. I just care about the top, so it's x times x plus 3 equals 2 times 2x. So if I multiply that out, I get x squared plus 3 equals 4x. It's a quadratic, so I'm going to move this over by subtracting 4x. So x squared minus 4x plus 3 equals 0. Okay, I'm going to factor it, and it's a double negative, and it's 3 and 1. So x, and this is equal to 0. So x minus 3 equals 0. Add 3. X equals 3. And add 1. And I get x equals 1. So what can't x be? So look at the original problem. X over 2 plus 3 over 2x equals 2. What can't x be? Well, I don't care about the top here. That doesn't matter. Tops don't matter at all. I'm just looking at the bottom. So 2x equals 0. Divide by 2. X is 0. So that's what x can't be. Are any of these 0? Nope. So my answer is 3 and 1. Okay, that's it. Not too bad. Okay, so let's get into ones that just a little more difficult here. Got a few more examples to do with you guys. X over x plus 9 equals 9 over x plus 9 plus 2. Well, what's your LCD? Let's put a 1 underneath here. Well, it's x plus 9. That's actually really easy, right? So LCD is x plus 9. So I'm going to multiply this one by x plus 9 over x plus 9. Alright? So I get, I cross these off because I don't care now about the denominator. And I get x equals 9 plus 2 times x plus 9. So x equals 9 plus 2x plus 18. I'm going to subtract 2x from both sides. I get negative x equals 9 plus 18 is 27. Divided by negative 1. X equals negative 27. That's it. What can't x be? Look at the original problem. I have an x plus 9. It's the only thing I have in my denominator. So I set that equal to 0. And it's pretty obvious. Even before you solve it, it's obvious. What is an x equal to? Negative 9. So x equals negative 9. So x can't be negative 9. Is it negative 9? Nope. Good to go. That is my final answer. All right. Another example. 2 over x. 2 over x minus x over 8 is equal to 3/4. So what's your LCD? Well, I've got an 8, I've got a 4. So just between the 8 and the 4, isn't the 8 the LCD? Because 4 goes into 8 and 8 goes into 8. And then you have another x. So my LCD is 8x. Okay, so I multiply this one by 8 over 8. This one by x over x. And this one by 2x over 2x. Okay, I have 8x on the bottom for everything. Cross it off. Don't need any more. I have 8 times 2 is 16 minus, 16 minus x squared equals 6x. Move the 6x over. And you know what? As opposed to moving the 6x over, I am going to move this over to this side. And you're like, well, why? Well, I don't want to deal with the negative x squared. I only want positive values. So I'm going to subtract 16 and add x squared to both sides. Okay? And I get x squared plus 6x minus 16 equals 0. And then I factor that, x and x, plus 8 and minus 2. So I solve that, x plus 8 equals 0, and subtract 8, x equals negative 8, and add 2 to all sides. So x equals 2. So 2 and negative 8. Go back to my original problem. What can't x be? Well, again, it's kind of hard to read that, but it was 2 over x minus x over 8 equals 3/4. The only thing I have to look at is this guy right here, and x can't be 0. Are we good to go? Yep. Answers are negative 8 and 2. Okay? Not too bad. Okay, I got two more examples, and then we're done. Okay. 3 over x squared minus x plus 5 over x minus 1 equals 2 over x. A lot more complicated, but not that bad. The first thing you got to do, just like with rational expressions, math fans, is you have to factor. So right here, I need to factor that, and I can factor an x out of there. So I get x times x minus 1. Okay, so that is actually your LCD. X times x minus 1. So let me just rewrite this again. 3 over x times x minus 1 plus 5 over x minus 1 equals 2 over x. So what do I need to multiply the first one by? Nothing. It's got x times x minus 1. What do I need to multiply this one by? X over x. Because I need x times x minus 1. And what do I need to multiply that one by? X minus 1 over x minus 1. That gives me x times x minus 1. Okay? So again, I don't need those denominators anymore. And I have 3 plus 5x is equal to 2 parentheses x minus 1. So I get 3 plus 5x equals 2x minus 2. And I'm going to subtract 2x from both sides and subtract 3 from both sides. So I get 3x equals negative 5. And I divide both sides by 3. So x equals negative 5/3. What can't x be? Well, here and here. Well, this one's just a combination of the two, so I don't have to worry. It's actually, I can do both of this one and this one. So x minus 1 equals 0. Add 1, x equals 1. So x can't equal 1. And this one's just x can't equal 0. Do any of these equal 1 or 0? Nope. So that's my answer. Okay? Sounds good so far? Okay, last example. 4x over x minus 4 equals 16 over x minus 4 plus 5. Well, that's kind of nice. Over 1, the LCD is equal to x minus 4. So I just need to multiply this one by x minus 4 over x minus 4. All right. And I multiply that out, or I cross off the bottom now, and I get 4x is equal to 16 plus 5 parentheses x minus 4. So 4x equals 16 plus 5x minus 20. And I subtract 5x from both sides. I get negative x equals 16 minus 20 is negative 4. Divide by negative 1. X equals 4. Sweet. Okay, let's go back to our original problem. What can't x be? You guys need to ask that question every single time. You cannot forget. So x minus 4 equals 0. So I add 4 to both sides. I get x equals 4. So x can't be 4. Oh! Warning, danger, danger. X equals 4 though. But I just said x can't be equal to 4. So it can't be one of my answers. Because if I stuck a 4 back into the original problem, I get 4x over, or 4 times 4, 16 over 0. You can't have that. So my answer is NSB. No solution, baby. Okay? So that's why you always have to check it at the end. And but that's it. That's how you do these kind of problems, guys. It's really not that bad. Same thing as rational expressions, except you cross off the denominator and you solve at the end. Okay? So that's it, math fans. Good luck to you, and have a nice day. Goodbye.